now we're going to continue with the second point that talk about the triangles that can be constructed from the following set of 3 points. By finding side length, classify each triangle as scalene, isosceles, or equilateral. So the concept here that I need to remember is what is a scalene triangle, and this is just a triangle that has 3 unequal sides. And isosceles is the one has 2 of its 3 sides that have the same length, that are equal. And the last one, equilateral, is when its 3 sides are equal in distance. The length are the same for the 3 sides. Here, in this problem, we're going to get 3 points. And from those 3 points that we know we can form a triangle, what we have to do is measure the distance between those 2 points. To do that, we'll need to use the formula for the distance. Simple. So what we're going to do first is understand. I'm going to write all the points here. Okay, that's the first step. So I'm going to have the first point that's A, that is coordinate is 0 and -2. B, that is 1 and 2. And C, that is -3 and 1. So as I did before, I just set my point in that form, so I know all the numbers that are on the left represent the x, and all the numbers that are on the right represent the y in the coordinates. Now we know that a triangle has 3 sides, has 3 points, A, B, C. Okay, so how do I know this one is a scalene or isosceles or equilateral? Easy, just find the distance between the points. So there is 3 distances that we need to find. The one is AB, then BC, and AC. If you see, I was doing AB, BC, and I should say CA, but the rule is we always write in alphabetical order, so that's why I didn't write CA, I write AC. So, as I said before, the way to find those distance is by using the formula of the distance, and that is equal to the square root of x2 minus x1 square plus y2 minus y1 square. Now, simple, just we have to replace those points. So let's start with the first point, first distance, AB, and what we're gonna do is just replace. So that distance should be equal the square root, and what is my x2? So here, what I need to decide is which of those 2 points is going to be the first and the second. It doesn't matter. I just choose 1 and 2. So my x2, if you see here, x2 should be equal to 1 minus my x1, that is a 0, all that square plus my y and 2, my y2, that's a 2, and my y1. If here, to I'm going to skip a step, actually I should have minus 2, and I know the rule of the sign that minus become positive, is the addition. So it's 2 plus 2, and all that squared, and everything inside my square root. And now, easy, I just have to simplify. So here I know 1 minus 0, it's 1 square. 1 square is 1, plus 2 is 4. If I square that, it's going to be equal to 16. 1 plus 16 is equal to 17. Very good. Done. So I know that the first distance is the square root of 17. Now, we are going to continue and we're going to do the second side, BC. So my second side is BC. Okay, so now here I need to decide if my point, which one is going to be that the one I'm looking for. It's this. Let's choose that B is 1, it doesn't matter, and C is 2. Okay, now we follow the same steps and I make sure to not make any mistakes. So x2, so this is my x, this is my point 2, it's equal, let's change color, negative 3, then minus x1, here my 1, x1 is a positive, so minus 1, all that squared plus my y2 is 1 minus y1, that is 2, all that squared. Fantastic. So now I don't forget to close my square root. Remove here. I just have to do the next step, that is just simplify my expression, negative 3 minus 1, that become negative 4. This time I'm gonna keep the negative 4, okay, to make sure that I don't make a mistake with the sign, okay, and 1 minus 2 become negative 1, thank you, almost did a mistake, I'll erase this. And everything is inside my square root. Simple. Remember that when you square a negative number, this one becomes positive. So the square of negative 4 is 16 positive, and the square of 1 is 1. That's it. Oh, look at that. Is this the square root of 17? Yes, it is. Interesting. So far, I can say that my triangle is isosceles. So now, let's find out if it is an equilateral. So, if we find that this side is the square root of 17, definitely is an equilateral triangle. If not, we are gonna have an isosceles. Okay, so now again we decide which point is first and the other one second, so it doesn't matter, you know that. 1, 2, simple. x2, y2, x1, y1. Let's solve this next side that we're looking. So now we have to do is do our last side, that is AC. We say that the point A is our first point. Okay. So you don't see it here. I'm going to write the coordinate of each one. 0, negative 2, and C is negative 3 and 1. Okay, and xy 1, 2. Okay, let's do it. D is my distance I'm looking for. my square root sign, x2 negative 3 minus x1 0. Fantastic. Should I write minus 0? I don't need to, but this time I will. Plus y2, that is 1, minus y1. Minus minus, we say that is positive 2. Fantastic. So just by looking the expression, I already know that is not going to be equal to the radical of 17. Let's see what is that equal to. Negative 3 minus 0 is negative 3 squared, 9. Plus 1 plus 2 is 3. If I square that, that is 9. And is equal to the square root of 18. And right away we can say this is a isosceles triangle. Don't forget that to leave the radical in the simplest form. We know the 18 is 2 times 9, and this 9 can go out of the radical, because if you use the properties, is 2, the radical of 2 times the radical of 9, we know this is equal to 3. So this is my final simplest form of the radical. Now I can say that the 3 points form an isosceles triangle. There you go.